All right, perfect. Perfect. All right, so I am back. We're going to start with problem number 22, 24, and then see if we can get to 28, but at least 22 and 24. So let's take a look at those problems on your review. Bring those up. On 22, you'll notice a couple things on 22. So first of all, they give you an equation to solve. That's the equation they give you. But then what you'll notice about the options, your choices, is that they're not giving you just numbers as solutions. So notice that they use the words. Basically, they're looking for is it a conditional solution? Does it have no solutions? Give me a second. I forgot the words for it. Is it a conditional solution? Is the equation an identity or a contradiction? And so really quick, let's talk about that vocab in case you forgot it from earlier in the course. So you guys are going to be fine with this. This is just a giant review of solving equations, and that's something you guys can do. But these, what do you call it? These vocabs. So conditional just means it has a solution. And so if we work this through and we solve it and we get a solution, it's conditional. Identity actually means that, so remember earlier in class, your teacher talked about most of the time when you solve an equation, you get a solution. However, there are a couple oddball scenarios. So occasionally when you solve it, you get an infinite number of solutions. Not one solution, but basically everything works, anything works. And then sometimes you get no solution, nothing works. So identity is just another word for an infinite number of solutions. And contradiction is just another word for no solutions. So that's what we're looking for here. We're going to solve this, and then if it's a solution, it's conditional. If it's infinite number of solutions, it's an identity. And if it's no solutions, it's a contradiction. So let's go ahead and do that. All right, so to solve this, like I said, this is just a giant review of equation solving. What you'll notice here is that we have some parentheses with multiplication. So before we even really try to solve it, which remember just means get the x by itself, we need to go ahead and distribute. So let's do that first. We're going to do 4 times x, 4 times 5, and also 4 times 3, and 4 times negative 2x on the right side. So on the left side, that'll give you 4x plus 20, 4 times 5. And on the right side, that's going to give you 12 minus, actually, 8x. And then we still have this extra minus 4x there. Good. Give me a second, y'all. I think I actually copied this down wrong. Did I? Possibly. Let me pause this and check. Hold on. All right, so I'm back and we're good. That is actually correct. We're going to get 4x plus 20 equals 12 minus 8x minus 4x. And so from here, something else you might notice is that on the right side, we have some like terms to combine. So in general, with equation solving, as long as you, as long as you have either distribution or like terms to combine, you want to do those first before we actually get down to the business of getting x by itself. So combining these, what we end up with is, so we'll still got 4x plus 20 on the left side. Then we'll have 12, and that should be minus 12x on the right side. All right. Now is really the question of how do I get x by itself? Notice that we've got x's on the left side and the right side. So one of the first things, your goal in equation solving is always to get the x by itself, but on one side of the equation. So there's really 2 parts to solving this, or 2 parts to your goal. You want to get x on one side of the equation, and then you want to get it by itself. So since we have competing x's, both sides, left and right side, we need to get rid of one of them. And in general, it's helpful to get rid of the negative one if you have one. Honestly, just simply so you have less negatives to deal with. There's a lot of, what I've seen in these classes, students make a lot of small mistakes that are mostly because of negatives. So it's not that you're smart and you know exactly what you're doing. There's just easy small mistakes that students make all the way up through calculus. So be clever about it. Be efficient. Get rid of the negatives when you can. So to get rid of this minus 12x, we want to do the opposites. The way you eliminate things is you always do the opposite of the operation. So that's plus 12x. Get rid of it. And whatever you do to one side, you need to do the other to keep things balanced, to keep this equals. So we'll add 12x to that side. And so what you end up with then is 16x plus 20 equals 12. And then from there, what we want to do, now we want to try to get the x by itself by taking anything you see on that left side that's not an x and eliminating it. And again, eliminating means doing the opposite of the operation that's there. So this plus 20, I'm going to subtract 20. I'll do the same thing to the other side to keep the equals, to keep it balanced. So we get 16x equals actually negative 8. And then we're going to do the opposite. 16 is being multiplied, and the opposite of multiplication is division. So we'll divide by 16. And we get x equals, when you reduce that, you get negative 1/2. So when you divide by 8, top and bottom. So the solution to this equation is x equals negative 1/2, which means this is a conditional equation. Again, if it has an answer, the vocab term for that is conditional. But again, for what you might see on the final, if it has an infinite number of solutions, that's an identity. And if it has no solutions, that's a contradiction. Good. So that lays out number 22 for y'all. All right, and let's go ahead and look at 24. So 24 also has to do with equation solving. So 24 is the other word problem that I've been given to kind of help you guys through. And so again, what I'd like you guys to do is go ahead and read it, maybe pause the video, and then once you've read it, again, I want to summarize what it's trying to say, because there's a lot in there, and this is kind of one of those, you gotta understand the context. So let me explain a little bit of the context. This problem is talking about some stuff in physics, but it's some stuff we understand in everyday life. They've just coded it using a lot of variables. So what they've given you in there is they've told you that V, so the V, a little zero before that, so the under it, not before it. The way you say that is V naughts. They say that that's the initial velocity. So if you think about anything, pretty much anything we do, but especially anything, let's say you're throwing a ball, you're shooting a gun, you're jumping off a diving board, etc. Anything that is moving through the air and is affected by gravity, you start off with some speed. So initial velocity, that's all it means. Velocity is just another word for speed. So it's your initial speed. It's the speed you start with. Then once you throw that thing, shoot that thing, once you jump, your speed changes as you go. So they tell you that this is the initial velocity. That's initial. V is your velocity after that initial, after the beginning. So velocity, and velocity for this problem is being done in feet per second. And then they give you an equation. So they basically say that as long as something is launched in the air, your velocity is always going to equal V naught minus 32 times t, and t is just your time in seconds. So you can track or you can calculate the velocity if you know the initial velocity and if you know the amount of time the thing has been in the air. Then again, we've been talking about, that last sentence is often where they give you the big thing that you need. The last sentence really, then they give you a bunch of intro and then they actually tell you what they want. So what they say is find V naughts find the initial velocity if the velocity after 4 seconds is 22 feet per second. So in some sense, they do backwards. Like this equation calculates velocity if you know the initial velocity and you know the time. And notice what they're doing there is they want you to find this if you know the velocity and if you know the time. So they give you some information about the velocity and the time, and they want you to go back and calculate V naught. And we can do that because we can solve an equation. This is basically how all of science works. As long as you got an equation for it and you plug in the stuff you know, you can go solve for the thing you don't know. So let's do that. So we got V equals V naught minus 32 times t, but they tell me that my V, my velocity, is 22 feet per second. They tell me that my time is 4 seconds. And they want me to go ahead and solve this thing or find V naught. So let's solve this equation. Again, one of the things you might notice here is that before we even really try to get V naught by itself, there's some multiplication here we should do. So we got 32 times 4, or negative 32 times 4. And when you multiply those, so we're gonna keep the 22. But when you multiply those, you should get what? 128. So minus 128. 22 equals V naught minus 128. And then all we got to do is get this thing by itself, whether it's in, again, we just did X in the last problem, but whether it's an X, a Y, a B, a pig, whatever, all you got to do is get it by itself. We got to take this minus 128 and just eliminate it. And the way you do that is the opposite. So we're going to add 128. And we'll do that to both sides to keep the equals. And so we end up with, what is that, 150. So V naught is 150 or 150 feet per second. So the answer here is 150, and you just want to make sure to use the units that they told you in the problem that the velocity is 150 feet per second. And that's the answer for that. And I'll end this particular video with that. Since these are both on equation solving, we'll end with that. And the next video that I bring to you guys will knock out the rest of the problems. Number 28, and then 31, 39, and 40. All right, so good stuff. See you guys at the next video.